Hi, my name is Andrew Harp. I am an adjunct faculty member in the Earth Science Department. Today we're doing our last lab in the General Earth Science course, and we're doing solar system evaluations and investigations. We're looking through the telescopes to image different sunspots that are on the sun currently, measuring their sizes and seeing how big they are relative to the size of Earth. And we're also doing a scale model of the solar system where we can see the sizes of the planets as well as how far they are based off of the sun being just the size of a light bulb. And at that scale, Pluto is 200 meters away from the 1400 building somewhere alongside the cafeteria. And so what we're going to be doing is we're going to be using this really long measuring tape to measure our distances between our different planets. And we're going to start out with the closest one to the sun. And what is the closest planet to the sun?
Mercury.
It's Mercury. And what's cool about Mercury?
It's tiny.
It is small, very small, right? And how far is Mercury from the sun?
We are at 0.61.
So it's 58 million kilometers away. And if we divide 58 million by 30 million, then we should get somewhere around 1.9 meters. So if we look on our tape here, we can go out to, here's 1 meter, and then here's 1.9 meters. And so I'm going to put a little stand here, and we're going to show you Mercury. Here is Mercury, and it is that dot that's on there. That's a little grain of sand. That is the size of Mercury at our scale. Poor little Mercury all by itself, that tiny little thing. And so we're going to put that at its scale distance model of 1.9 meters. So right here. So here's Mercury orbiting around the sun. We can go ahead and turn the sun on. It's a little bright. All right, but it's going to get dimmer and dimmer the further we go out.
Hi, my name is Katie Adams. I'm here at Shasta College, and we're running some telescopes in an General Earth Science class. This is Professor Harp's class, and we're actually observing sunspots here. That telescope is actually more zoomed out, so you can see the entirety of the sun. This one's a little more zoomed in, so you can get some close-up view of the sunspots. And then this one is so you can actually see the edge of that sun and even get a closer view of those sunspots. As we will do this usually spring and fall, because sunspots usually change over time as it goes through that 11-year solar cycle. So